Hi everyone, welcome back to the channel. Now let's continue the discussion on students t-test. In the last video we discussed about t-score, types of t-test and degrees of freedom. Now let's do the calculation part. For that we will divide the whole process into steps. Step 1, form the null hypothesis and the alternative hypothesis. Step 2, perform the experiment and collect the data. Step 3, select an alpha level. Step 4, calculate the total degrees of freedom. Step 5, find out the t-score that corresponds to the alpha level and the degrees of freedom from t-distribution table. Step 6, figure out the type of t-test and accordingly calculate the t-score. Step 7, compare the calculated t-score to the t-score of alpha level so as to reject or accept the null hypothesis. Now let's demonstrate it with an example. I want to test if the new diet is going to decrease the weight. Step 1, form the null and alternative hypothesis, which will be that the new diet does not and does reduce the weight. Step 2, perform the experiment and collect the data. So here I have taken 20 people randomly from the population and divided them into two groups, where group A will not take the diet and group B will take the diet. Then after 3 months, I measure the weight of each person in both the groups. As you can see, there is a difference between the means of the both groups. But is it sufficient to say that the diet is working? For that, we go to step 3. Step 3, select an alpha level which I will choose to be 0.05. Step 4, calculate the total degrees of freedom, which will be the sum of degrees of freedom of each sample. Degrees of freedom is n minus 1, so total degrees of freedom will be 18. Step 5, find out the t-score that corresponds to the alpha level and degrees of freedom from the t-distribution table. Here we will use the one-tailed t-distribution table. For alpha level 0.05 and degrees of freedom 18, t-score is 1.734. Step 6. Figure out the type of t-test and calculate the t-score. Since I have taken two groups giving treatment to only one, therefore it is an independent or two-sample t-test. Here we will use the following formula for t-score. Using the values, we will get the result 2.42. Here one can change the positions of mean, leading to minus 2.42 as t-score, but it doesn't matter since the absolute value of t-score is considered for further calculations. Step 7. Compare the calculated t-score to the t-score of alpha level. Here t-score we calculated is more than that of alpha level. To understand what it means, let's look at the t-distribution graph. T-distribution graph shows the probability of different t-scores just like normal distribution shows probability of different values. Just to revise, is p-value of data is the probability of getting the data if the null hypothesis is true. Whereas alpha level is the p-value that sets the bar to decide where the p-value of data is high or low. The orange area is the alpha level with area of 0.05. That is, it contains the probability of values equal to and greater than the corresponding t-score. Now t-score we calculated from the data is more than the alpha level t-score and will therefore have probability area less than the orange area, or say the p-value of the data is less than the alpha level. Since the probability of getting the data if the null hypothesis is true is low, therefore we will reject the null hypothesis and accept our theory that the diet is decreasing the weight. Now let's say that I change the design of the experiment. Now instead of taking two groups, I measured the weight before and after giving diet to only one group. So say step 1 to 5 will remain the same. Going to step 6, this kind of t-test where measurement is taken on the sample before and after treatment is called paired t-test. We will use the following formula. Here M and S are the mean and standard deviation of differences of each pair of values. Remember to calculate them carefully. Accordingly, we will get the t-score 6.73. Moving to step 7, we can see that the t-score of data is more than the t-score of alpha level. Therefore, again, the p-value will fall in the orange area. That means the p-value of the data is less than the alpha level. The null hypothesis will be rejected and we can say the diet has reduced the weight. Now for the last type of t-test, where I compare the after diet weight measurement with the population data. Here I am considering both increase and decrease in weight, making it a two-tailed test. So step 1 to 5 will again remain the same. T-score for alpha level will be taken from two-tailed distribution. In step 6, since it is a one sample t-test, following formula will be used. Say I am taking the population mean randomly as 75. The t-score then will be 4.45. Step 8. Since t-score of data is more than t-score of alpha level, therefore p-value will be less than the alpha level. Thus, the null hypothesis will be rejected and we can say that the diet has affected the weight. This kind of t-test is especially helpful when we actually know the normal range. For example, we know normal hemoglobin range is 12 to 14 or normal blood pressure is 120 by 80 and so on and so forth. Here I have just demonstrated with a few examples, and I'm really sorry if some of the calculations will go here and there. This is just to explain the concept. That's it for today. Thanks for watching. If you learned something from the video, then please like, share and subscribe the channel.